Hello friends, welcome to Quickfire Numerical Practice Series for GATE 2021. We are going to discuss a numerical on DIT FFT, and before I start the numerical, let me tell you this series is aimed as a ready reckoner for numerical solving. In this series we are not going to discuss the theory or the derivation of the formulas. So DIT FFT is decimation in time fast Fourier transform. It's a special algorithm for solving problems of DFT, discrete Fourier transform. So if we are given a discrete signal in time domain such as this with 8 number of samples, we might want to solve it using DIT FFT because it's a faster algorithm than DFT. If you wish to know why it is faster, you might see my previous videos, the lecture videos on this, but in this video we'll solve this thing as quickly as possible. So the first step is to see what all samples do we have. So we have sample number 0 as 1, sample number 1 as 2, and so on and so forth. So we have 8 samples in total, and we need to write these samples on this side in the bit reversal order. So let's calculate the bit reversal order first. So we write down all the sample numbers starting from 0, 1 to 7, and when you do the reversal of bits, this becomes 0, 0, 0, this becomes 1, 0, 0. The idea is to reverse the bits and see, we get, this is the bit reversed order, so we get x0, and the second in place is x4, the third in place is x2, and fourth in place is x6, and so on and so forth. So we write down these samples like this, x0, x4, x2 in this order. So this order needs to be bit reversed order. That's the first thing you need to remember. And then what we do is we take up 2 samples and we draw a cross between them. The first sample is sent as it is. The second sample is sent with a weight of 1 here. So this is the direction, this is the direction, and this direction has a multiplier of -1. In a butterfly diagram, you need to remember that when you go from this point to this point, you have a multiplier of 1. When you go from this way, you have a multiplier of 1. When you go to this way, the multiplier is 1. Only this has the multiplier -1. So this is one thing that you need to commit to your memory, and that is what I've done here. The multipliers are 1 here in the bottom line. Another way of remembering is that the bottom of the x has a multiplier of 1. And when you have just 2 samples, the weight of the bottom sample is 1. That's what you need to remember. You need to commit to your memory. And this is sometimes known as W00 or W10, the first stage's weight, and there's just one weight here, so its value is 1. And then it is pretty simple. You simply calculate it. 1 and 4 are being added and gives me 5, and then 1 and -4 gives me -3. 3 and 2 gives me 5. 3 and -2 gives me 1, and that is how I've calculated everything. And of course, before sending this upwards, sending this bottom signal upwards, I multiply it with weight, and incidentally the weight is 1. If we go to the next stage, you take up 4 samples. That's what decimation in time does. It takes up 2 in the first stage, 4 in the next stage, but that's the theory part. And the first 2 will be sent as it is. The next 2 will be sent along with the weights. So you need weights here. And what are those 2 weights? Those 2 weights are 1 and -j. So the first stage weights are 1. The second stage weights are 1 and -j. So you put a 1 and -j here in the first group, and 1 and -j here in the second group. And rest everything is simple. For every cross, the bottom line is -1. So you put a -1 here, -1 here, -1 here, and -1 here. Then you start sending the signal. So this is, for example, this is 5 going this way, and the other thing is coming here 5, and 5, so this should be 10. So this is 10. So this is 5 and this is again 5. They are being added to give me 10. Now let's look at this part. The first input is -3, okay, and the second input is 1. So this multiplies with -j, which is the weight, so it becomes -j, and -j again multiplies with -1, which is the multiplier, so it becomes +j again. So when we add these two, we get -3 plus j. You need to be very vigilant to solve all these, because sometimes you encounter two minus signs, one after the other. So vigilance is the key. You need to be very patient to solve this. And you get the output on the second stage also. And in the third stage, we take up a group of 8, and 4 of them go as it is, and 4 of them go along with the weights. So what are the weights for the third stage? So weights are going to be attached here, 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 and here. And I've written down the values of the weights here. And so this is -707, -0.707j. So you should note down these weights. And rest everything is pretty simple. You multiply the input with the weight, and then you send it either upwards or just in the forward direction. But if you go in the forward direction, you'll need to multiply it with a multiplier of -1. Going upward is just simple because the multiplier is 1. And again, when you do the calculations, you get all the values, and these values are x of k, and these are in the right order. So in other words, you start from x of k 0. So this is the value of x of k at 0. This is the value of x of k at 1, 2, 3. So if you give the input in the bit reversed order, you'll get the output, which is the Fourier transformed signal x of k, because the objective of this question was to find x of k. So this is x of k. So you get 8 samples, and all these 8 samples are x of k. And you could be asked to tell the value of 5th sample or 3rd sample or whatever. So this is sample number 0, 1, 2, 3, 4, 5, 6, and 7. And this is 0, and this is 8 samples in all. So that is how you can quickly solve a DIT FFT numerical. Very quick algorithm, and you simply need to keep track of weights. So the thing that needs to be committed to your memory are the weights on the 3 stages, and this minus multiplier at the bottom of the butterfly diagram cross. Well, that's about it for today's tutorial. I hope this quick fire tutorial on solving this numerical was of help. If you liked the video, give it a thumbs up, consider subscribing. I'll make this video every day till GATE 2021 exam is over, and I'll see you around in the next video. Take care. Bye bye.